the next to last section that we're going to talk about here is called the Michael reaction or Michael addition, sometimes referred to as conjugated addition or 1,2,1,4 addition. So the reaction occurs between an alpha-beta unsaturated carbonyl compound. So if you look down below, here's your alpha-beta unsaturated carbonyl. So that's the same as the dehydrated aldol product, right? Now, as far as how this reaction proceeds, we number these carbons or these atoms as 1, 2, 3, and 4. And then we can look at some resonance here. So we can take these electrons here on our carbon, oxygen double bond, pull them up here to our oxygen. That would put a negative charge up here and a positive charge right there. So in that case, we see an electrophilic position at number 2. We could take our electrons here and pull them over to this position. Right, that would leave us still with our negative charge here, but a plus charge here at number 4, and that's called a 1,4 addition. So if we add to the carbonyl carbon, right, that's carbon number 2. Or we can add to the beta carbon, which is carbon number 4. So that's your 1,2 and your 1,4 addition here. So let's look at case number 1 here. So case number 1 deals with nucleophiles that have a high polarizability. That turns out to result in an addition that's a 1,4 addition. So if we look at our reaction here, we have our nucleophile coming around here, making a bond with that carbon number 4, electrons coming over just like so, and then lone pair put up on our oxygen, right? So we added to our 4 position essentially there. So then we protonate that, and then we do a tautomerization, and we get our final product there. Now it turns out nucleophiles that have lower polarizability, and we'll talk about that a little bit more down below, but a low polarizability such as alcohols and hydride, for example, those tend to add in a 1,2 addition, Grignards, organolithiums. So again, the mechanism is fairly straightforward. Nucleophile comes over here, attacks our number 2, and then we come up and push those electrons up here, and then we protonate that, right? And in this case, we don't have an enol or anything, but that is a potential stereocenter that might form. Well, let's look at the types of Michael donors that we actually have here. So there's types of donors that are all listed down below. Here's your beta diketones, beta keto esters, enamines, dialkyl cuprates, beta ketonitriles, and alpha nitroketones. Michael acceptors are typically going to be alpha beta unsaturated ketones, right? Most commonly, we see but-3-ene-2-one, also known as methyl vinyl ketones. So that's a methyl, and then this is a vinyl group. And then there's a lot of other ones that can be used here too. So you'll see those pop up as you go through and look at different examples throughout your problems and stuff in your textbook. All right, again, so just to reiterate here, you have your different type of Michael donors, and recall that most of these Michael donors that we see down here below fall into the category of being enolates, which will add in the 1,4 orientation.